Hello guys, this is Sanket here from Coding Blocks, and today we are going to discuss a very interesting problem, that is graph on an array. So let us see what the problem says. The problem says that we will be given an integer sequence of a1, a2 up to an, and we need to modify this sequence to a new sequence b1, b2 up to bn, where every integer of Bn lies between 2 and 50, both inclusive. Okay, so let us see what the problem says after it. The problem defines an undirected graph G with n vertices numbered 1 through n. For each pair of different vertices I and j, there is an edge between I and j if and only if Bi and Bj are coprime. So let us see what this line says. So this line mentions about the undirected graph. So let us take an example of a graph with vertex v1, vertex v2, vertex v3 and vertex v4. So the problem defines that there will be an edge between any two vertices if and only if the two vertices are coprime. So what do you mean by coprime? Two integers are said to be coprime if the greatest common divisor of the two integers comes out to be 1. For example, GCD of 5 and 9 comes out to be 1. So 5 and 9 are coprime. And GCD of 8 and 16 comes out to be 8. So 8 and 16 are not coprime. Okay, so for an edge between V4 and V1, the GCD of V4 and V1 should be 1. The GCD between V3 and V2 should be 1. And the GCD of V1 and V3 should be 1. Okay, so you should choose the sequence B in such a way that G is a connected graph. The number of elements which need to be changed to obtain B from A should be minimum possible. So we have to modify the sequence A to the new sequence B such that B becomes a connected graph as defined in the problem, and the number of elements required to change A to B should be minimum. Find one such sequence B and the minimum number of required change. Okay, so let us take an example in the given test case. So in the given test case, the two elements are 2 and 3. So the GCD of 2 and 3 comes out to be 1. So there can be an edge between these two. So this comes out to be a connected graph. So now let us see what a connected graph is. A connected graph is defined as a graph where we can reach from any one vertex to any other vertex easily, and there should not be an unlinkage, or I might say there should not be any such component in a graph from which we can't reach through an another edge. For example, suppose this is a graph. So this is a connected graph, as from 1 we can reach to 4, and from 2 also we can reach to 4, from 2 we can reach to 3. So from every vertex we can reach to any other vertex. This is known as a connected graph. Okay, so now let us take an example 2 and 4. Okay, 2 and 4. So the GCD of 2 and 4 comes out to be 2. So there cannot be a direct edge between 2 and 4. So we need to modify this sequence. We can modify this sequence as 2, 3, as we change 4 to 3 with one step required. And now 2 and 3 are coprime. so there can be an edge. So this is a connected graph. Okay, so let us take another example. Let us take a sequence like 2, 3, 6 and 9. Okay, so can we make a connected graph here? I guess we should try it. So we can have an edge between 2 and 3, as 2 and 3 are both coprime. Now 6 cannot have an edge with 2, as GCD of 2 and 6 comes out to be 2, and 6 cannot have an edge with 3, as GCD of 3 with 6 comes out to be 3. So there can't be a direct edge between 6. So 6 has to be an isolated element. For 9, there can be a direct edge from 9 to 2, as GCD of 2 and 9 comes out to be 1. So here we can see we need to modify 6 such that the whole graph becomes connected, as this is not a connected graph. Not a connected graph. So what we can do is modify 6 as 7, and then we can add 7 with any of the vertices, as GCD of 7 with 2 is also 1, 7 with 9 is also 1, and 7 with 3 is also 1. So we can add 7 here, and now this is a connected graph. So an important observation to be made is that here we can obtain the sequence B from the sequence A by doing at most one swap. Either we will require no swap, or we can achieve the sequence B with maximum one swap. So how I am saying that? Let us take an example. So suppose we have been given a sequence like 2, 4, 6, 8, 10. So here you can see all the elements are having GCD greater than 1 with each other. For example, GCD of 2 and 10 is 2, and that is not equal to 1, and same applies for all the elements. So can can we make this as a perfect sequence that can make a connected graph? Yes, we can do that. We can swap any element with a prime number greater than all the numbers present in this array. So for example, let us swap this 2 with 47. Now GCD of 47 with 4 is 1, 47 with 6 is also 1, 47 with 8 is also 1, and 47 with 10 is also 1. So we can make this graph like this. 47 has an edge with 4, with 6, with 8 and with 10. So here you can see by doing at most one swap we have achieved this figure. Okay, so what are all cases we can have here is that suppose all the elements of the array are equal. For example, 4, 4, 4, 4. Here also you can see there is no coprime pair available in this array. So what we can do is swap any 4. For example, this 4 with 47, and now we can see we can have a connected graph. So here also we did at most one swap only. And in some cases we will also not require even one swap. For example, 2, 3, 10 and 7. So here we can see 7 has an edge from 10, from 3 and 2. We can also make this figure as 2, 3, 10 and 7. So here there can be multiple graphs, and we will require 0 swaps. So what observation we made is that we will either require one swap or 0 swap to achieve the B sequence. Okay, so how can we detect if we require one swap or zero swap? So let us now again take an example: 2, 4, 6, and 9. So here we can see 2 cannot have a direct edge from 4 and from 6, but 2 can have a direct edge from 9. For 4, it can have a direct edge from 9. But for 6, it cannot have direct edge from 2, from 9, or from 4, because GCD of 6, 2 is 2, 6, 9 is 3, and 6, 4 is also 2. So all of these are not equal to 1. So 6 cannot be attached with any of the following. So 6 will have its own different component. So we can see in any case we can have either one component or two components. As in this case we are having two components. There can be situation where there can be multiple components also. But if we have more than two components or equal to two components, then we will say that we need to have at least one swap, or I can say at most one swap, because we have observed the fact that by doing at most one swap only, we can achieve the B sequence. So the problem reduces to the fact that from the given sequence A, we need to find all the components, and if the number of components comes out to be greater than equal to 2, then we will do one swap, or we will have zero swaps. Okay, so what three steps we have to do is that find the connected components, swap any element with a given prime number, and then we are done. So now let us look at the implementation part for this problem. So the input format is like we will be given an integer t which will describe the number of test cases. Then we will be given an integer n and the given array. So let us start writing the code. Okay, so the name of the problem is graph on array. So we will have our header files, the main function, and here we will first input the number of test cases, then we will input n. After having the input of n, we will prepare an integer array of size n and then take the input in this integer array. Okay, so now before proceeding further, I will make two functions which will help in our code. So the first function is to calculate the GCD. So this function will return the GCD of two numbers A and B. So we know by Euclidean algorithm we will write the code as follows. If B is equal to 0, then we will return A, else we will return GCD of B comma A modulo B. Okay, also we will make a function check equal which will check if all the elements of a given array are equal or not. So if we iterate over the whole array, we will iterate from I is equals to 1, and if any two pairs not come out to be equal, that is if anywhere the element on which we are currently on and the previous element are not equal, then we will return false, as the whole array is not equal. And if we iterate over the whole array and we are not returning anywhere, then we will return true. That is, the whole array is equal. So now we are done with our functions of GCD and check equal. So now what I will do is do some preparation for finding the connected components. Firstly, I will import vector and list. So what I am going to do here is that for every element, for an example 2, 4, 6 and 9. For for this example, what I will do is prepare a list AI and push all these elements into this. Now also I will prepare a vector of integer num and another list of integer as li. Now, what I will do is that for each element in AI, I will try to push it into the vector along with those elements which are directly co-prime with the current element in AI and can form an edge with AI. Also, I will prepare a counter taking into the fact that whenever we have more than one such component, we don't need to do anything else again and again, and we will break through our loop. So let us see the code part and then we will try to debug this. Okay, so now I will prepare a list of integer AI, and one by one I will push all the elements into AI. And this should be array at I. Okay, yes. Also, I will prepare a vector of integers num and another list of integer li. Now, what I will do is prepare a counter as answer, and whenever answer is greater than 1, then we will break the process. Okay, so now what I will do is that while we are not done with every element of the list AI. So while not AI is empty, what I will do is that I will insert every element of AI one by one into the num. So AI dot front, and also I will remove that element from AI. So I will use pop front as this is a list. Okay, so now for every element that I am pushing into the num, I will check that how many elements are directly eligible for forming an edge with that current element which we have inserted in the vector num. So for int I is equals to 0, I less than num dot size I plus plus. So for every element in the connected component num, or I can say the vector num, I will find that if any of the remaining element can form a direct co-prime edge with any element of num or not. So while the remaining elements which are not inserted in num, remaining elements which are not inserted in num vector, what I will do is that I will get every element and remove it from the given list and check if the GCD of the element of the list and the element of the num vector is double equal to 1 or not. If it is, then I will insert this into our num vector, as it can be a part of our connected component, as it can form a direct edge from one element of the num vector. So I will insert this into num, and if the GCD is not 1, then what I will do is that I will push this element into the li list. So after we are completed with this process, so what I have what I have to do with li is I will assign li to ai once again, so that for all the components that were not found with the current element of num, we can find a better candidate with num for that element. So I will clear my li list, and I will increase the counter for answer. Okay, so why I have increased the counter for answer here is that if we come out of this for loop, this given for loop, then we know that we have prepared one connected component. And if we come out from this for loop again and again, then we will realize the fact that we have more than one connected components. So we will clear our num array so that we can prepare another connected component. And if at any instance answer is greater than 1, then we don't need to iterate further and we will break out of this loop. Okay, so if answer is 1, that is we have only one component. So what we will do is that we don't require any swaps, and we will print the whole array as it is. So we are printing the whole array as it is, because all the elements can form a direct edge with some other element of the array without any hindrance. Okay, else if answer is not equal to 1, and if the whole array is equal in the sense all the elements of this array are equal, then what we will do is that if all the elements are equal and all the elements are equal to 2, then maybe we can swap with any number. Maybe I can swap with 47, or maybe I can swap with 3. So let us check if all the elements are 2, or this can be checked by checking the first element only, because we know the array is equal. So if the first element is double equal to 2, then we will replace this element by 47. Else, okay, I should do like, if it is equal to 47, then I should replace it by 2. Else I should replace it by 47. Why I have done this here is because 47 is an element that can become a central node for all the remaining vertices, because it can form co-prime pair with every element from 2 to 50. So if the whole array is 47, then we cannot form 47 as a central node, because all the elements are equal and GCD of 47 with 47 is 1. So we will require a different number. You can use 2 or any other prime number here. Else, if all the elements are not equal to 47 and they are equal to some any other element, then we can swap just one element to 47 and make the 47 as central node. So let us see, if all the elements are equal, then what we can do is swap any element with 47 and make 47 as the central node. Also, if all the elements are 47, then we can't make 47 as a central node. So we will swap any element with, let us say, 2 and make 2 the central node. I hope this is clear. I hope this is clear to all of you. Okay. So now we will further increase our implementation part. So if the components are more than 1, and also all the elements are equal in the array, then we will do this process, and after this we will print the array. So I will copy the code from here and I will print 1 in the swap process. If the array is also not equal and it has more than one connected component, then what I will do is arbitrarily assign the first element as 47, irrespective of the fact that 47 may or may not be present in an array. We will discuss this scenario within a while, and then I will print the whole array. Okay, so let us take an example to see what I have done here. So for example, our array may be containing elements like 3, 5, 2, 47, 9 and 6. So here we can see the elements can be arranged like 3, 5, 2, 47, 9 and 6. But what if what if we have elements like 2, 4, 6 and 9? 2 can have direct edge with 9, 9 can have direct edge with 4, but 6 cannot have a direct edge. So what we will do is swap 2 with 47, and then we can have a direct edge of 6 with 47. So here we are realizing a fact that if the whole array is not equal, not the whole array is equal, and even 147 is present in the array, then there will be only one connected component. We can see by examples like 47 2, 47 3, 6. So here we can make it as 47 2, 3, 6 and 47. So that is what we have done there. Okay, so after doing all this, we will have the return 0 statement. So let us submit this code to CodeChef. Okay, so I'm opening the portal, I've copied the code, and now I'm submitting it. Okay, there's some compile time errors. Let us see what such errors are. Okay, so okay, that is AI. I have somewhere mentioned it as A. Okay, this is AI. This is AI. Okay, okay, I guess everything rest is fine, and we can submit it again. Okay, now I have submitted it again. Let us see what the answer comes. Again, a compile time error. Okay, so it says, so here I have copied the code and now I will submit it. Okay, so let us see what the output comes as I have submitted it, and as you can see, I have got the correct answer and the execution time is 0.34. So I have got it accepted here. So now let us again dry run the code and see what logic we have mentioned here. So what we are doing is that for a given sequence AI, A1, A2 up to AN, we are finding the number of connected components. And if these are greater than 1, then we know by at most one swap we can achieve the whole given B sequence as one component. Okay, so I hope you like the tutorial. I wish you all the best, and please like the video and comment your doubts on the video. Thank you.